cosine of 30 plus 60 degrees. I want to know, is that the same as just doing the cosine of each? Could I just distribute my cosine?
Yes.
Seems like a logical approach. If I worked each of these out, 30 plus 60 is 90. Cosine of 90, if we did our hand trick, is 0. Over here, cosine of 30 from the hand trick is radical 3 over 2. Cosine of 60 is radical 1 over 2, or 1/2. So are these equivalent?
No.
No. So with our trig functions, you cannot distribute that trig function. Instead, we have formulas. So we will have sum and difference formulas for sine, cosine, and tangent. Today we're just looking at the two cosine formulas. So cosine of A plus B, write these down on that sum and difference tab on your flip chart.
Well, we need to leave room for more.
You will have 6 total formulas on this page. So now we're doing examples in your notebooks. If I ask for the exact value of cosine of 75 degrees, exact value means in terms of radicals, not the decimal that our calculator would give us. So we do not know 75. That is not an angle that we memorize. But we can break it up. Think about the angles on our unit circle. 0, 30, 45, 60, 90. Could I rewrite 75 using 2 of those angles that I know? Let's write this as the cosine of 45 degrees plus 30 degrees. Now, we are just going to use that formula. So look at your formulas you just wrote down. Cosine of A plus B is cosine of A, so cosine of the first, times cosine B, cosine of the second, minus sine A, sine of B. So we still have to know these values from our unit circle or the hand trick. So 45 degrees, remember cosine radical square root of the bottom over 2. So cosine of 45 is radical 2 over 2. Cosine of 30 would be radical 3 over 2. Minus sine of 45, sine is the number of fingers on top, so radical 2 over 2. Sine of 30 is radical 1 over 2, or 1/2. So if I multiply, if both numbers are under a radical, you can just multiply them under the radical. So it's radical 6 over 4 minus radical 2 over 4. You can't actually subtract those. If you wanted, you could make one big fraction, but this is our answer. Nothing else we can do. So I would accept either of those. B. We have cosine of 17 pi over 12. In general, it's a little bit harder for people to think about what might add or subtract if you're in terms of radians. So we can always convert this into degrees. How do we change radians into degrees?
Pi over 180.
But we want to cancel the pi, so we'll multiply by 180 over pi. So this is the cosine. Let's see, pi's drop. 17 over 12 times 180. So that's 255 degrees. If you need to, pull out a unit circle and look at it. We need 2 angles from our unit circle that either add or subtract to 255. Pull out a circle if you need to, guys.
300.
Say that again.
300 minus 45.
Okay. You're welcome. Have a good weekend.
You too. Happy Easter.
Thank you, you too. Alright, so this is not the only option, you just have to find one combination that works. So now we can use our formula. Cosine of the first, cosine of the second, plus, it's a subtraction formula, so there's a plus in the middle, sine of the first, sine of the second. Okay. 300 degrees, what quadrant is that? Reference angle? 360 minus 300?
60.
Okay. So, for cosine of 300, in quadrant 4, all students take calculus. Cosine is positive. Cosine of 60 is radical 1 over 2, or 1/2. Cosine of 45 is radical 2 over 2. Sine of 300, in quadrant 4, sine is negative. Sine of 60 is radical 3 over 2. And sine of 45 is radical 2 over 2. So if I multiply this, we get radical 2 over 4 plus a negative, so minus radical 6 over 4. Is that okay? So this unit circle stuff hasn't gone away. We haven't used it in a couple weeks, but it's still there. We still need to know those values.
Since it is a common denominator, can we just do radical 2 minus radical 6 over 4?
Absolutely. Okay, C. Cosine of 173 degrees times cosine of 83 degrees plus sine of 173 degrees, sine of 83 degrees. This one's different. Can I do the cosine of 173 or the cosine of 83? Do you recognize anything about this? Yeah, it's the formula. Cosine times cosine plus sine times sine. It's this formula. So I gave you this side, you have to rewrite it using this one. So that's cosine of A minus B. So cosine, my A is 173 minus my B is 83. So 173 minus 83, 90. And cosine of 90? 0. So I could give you either side of the equation.
How would that work? Just get 0.
Wasn't all that much work. Let's do a couple proofs with this. Or at least one. So we've been doing all these proofs, they're not going away. If I said cosine of x plus 2 pi equals cosine of x.
You get the box in the side and try to solve it.
Which side would you box in?
Right side.
Okay. What do you have to do on the left? Well, we can't just distribute though, we have to use the formula. So it's cosine of the first, cosine of the second, minus sine of the first, sine of the second. We don't know cosine of x, but cosine of 2 pi we can figure out. 2 pi is the same place as 0. Cosine of 0 is radical 4 over 2, so 2 over 2, which gives us 1. Minus sine of x, sine of 2 pi, so sine of 0, 0. So we get cosine x times 1 is cosine x, sine x times 0 is 0, and we get the cosine x. So I could throw these in a proof if I needed to. One last example. What if I asked you to write this as a single cosine?
I'd say we're screwed and we should give up.
Oh, Josh. Have you learned nothing in my class?
Yes, math is complicated.
So we have cosine 3x times cosine 2x minus sine 3x sine 2x. Does this look familiar? It's the equation. It's the first one. I gave you the right side, you give me the left. So it turns into cosine of a plus b. My a is just the 3x, my b is the 2x. So cosine 5x. And that's your answer. Okay. We are stopping here today. We have some time, so I want you guys to start some problems and see if we have any questions.